Hi everyone, in this lesson we look at function notation. We introduce the idea of function notation. So we already looked at in the last lesson how a function is basically almost like a machine that takes in a value and spits out one single value. So the value that it takes as an input is an element of the domain, and the output value is an element of the range. So it's really important that each input value only has one output value. So to denote functions, we kind of have this special notation. So consider first the function y is equal to, let's do y is equal to 2x plus 1. We already looked at how y is equal to 2x plus 1 is a function because if you put in a single value for x, you get out a single value for y. So for each input, there's exactly one output. So there's a special way to denote that we could rewrite y as a function. We could rewrite y is equal to 2x plus 1. We could write this as f of x is equal to 2x plus 1. Now, this does not mean multiplication. So our function f, what it does is it takes in a value for x. And depending on what the value for x is, it's going to multiply it by 2 and then add 1. That's what my function does. Essentially treat this as though it's a machine. It's a machine that takes in x, multiplies it by 2, and adds 1. So if I wanted to put into my function the value, let's say 3, and I want to see what value I'd get out, well, I would do f of 3. That's how I'd write this. It means that I'm inputting 3 into my function. So when I input 3 into my function, well, it's going to multiply it by 2. It's going to take 3, it's going to multiply it by 2, and then add 1. And we can actually get the output now. If we input 3, we get 2 times 3 plus 1. 2 times 3 is 6. 6 plus 1 is 7. So f of 3 is just 7. Now, this also corresponds to an ordered pair on a graph. This would correspond to the ordered pair 3, 7. So we know that 3, 7 is on the graph of f of x. So let's go ahead and we will, we're going to continue to use this definition to do a couple example problems. So in this first example, we're asked to find f of 1/3, g of 2, and g of 1/2 for these functions up here. So let's do f of 1/3 first. So how would I write that? Well, I do f of 1/3 is equal to 2 times 1/3 squared. That's a 3 there, sorry. Let me write that a little bit neater for you guys. F of 1/3 is equal to 2 times 1/3 squared plus 5. This is equal to, well, 2 times a third, 2 times a third squared is 2 times 1/9. 2 times 1/9 is just 2/9. So we get that this is equal to 2/9 plus 5. Now, to add two fractions, I have to find a common denominator. A common denominator would be just to rewrite this as 2/9 plus 45/9, because 45 divided by 9 is just 5. So I haven't changed the value of this fraction. Now that I have a common denominator, I can add 2/9 plus 45/9, which is just 47/9. And remember that you don't add the denominators when you're adding fractions. You just add the numerators. So next we're asked to compute g of 2. So g of 2, and this is the notation that I follow. G of 2, remember that this does not mean multiplication. It means that I'm inputting 2 into my function. So g of 2 is equal to 2 times 2 minus 3 over 2 plus 5. 2 times 2 minus 3, well, 2 times 2 is 4, minus 3 is 1. So 4 minus 3 is 1, 2 plus 5 is 7. So I just have g of 2 is equal to 1/7. And lastly, just let me erase this, this little bit so I have some more room to write. Lastly, I'm asked to compute g of 1/2. So, oops, g of 1/2 is equal to 2 times 1/2 minus 3 divided by 1/2 plus 5. Now, 2 times 1/2 is the same thing as 2 times its reciprocal. So anytime that you multiply a number by its reciprocal, you always get 1. So 2 times 1/2 is 1, minus 3 is 1 minus 3 is negative 2. In the denominator, I've got 1/2 plus 5. Well, 1/2 plus 5 is 5.5, but we want to rewrite this as a fraction. So 1/2 plus 5 is 5.5, and we can write this as 11 over 2. So we've got negative 2 divided by 11 over 2. Division by 11 over 2 is the same thing as multiplication by the reciprocal of 11 over 2. So I actually get negative 2 times 2 over 11. Negative 2 times 2 is negative 4. And I really can think about this as 2 over 1. 1 times 11 is just 11. So moving forward, we're asked to determine the value of a such that f of a is equal to 13. So we want to consider what happens, like what value can I plug into f of x, or what value a can I plug into f of x in order to get 13. So let's write this as, first off, I know that f of a is equal to 13. And that is equivalent to, if we go up to what the algebraic expression for f of x actually is, it's 2x squared plus 5. So we want to say that f of a is equal to 13, which is equal to, I'm not subbing in, I'm subbing in a for x when I do this. So I have to sub in a for x, and I get 13 is equal to 2a squared plus 5, where all that I've done is I've replaced x with a. And now I can figure out what value for a gives me 13 for f of a. So now we've got an equation, and we can just solve this equation. If I subtract 5 from both sides of this equation, I get that 8 is equal to 2a squared. I can divide both sides of this equation by 2, and I get that 4 is equal to a squared. And now I can take the square root of both sides of this equation, or I can square root both sides of this equation, remembering that when I take the square root of both sides of the equation, I have to add a plus or minus symbol here. So a is equal to plus or minus the root of 4, and thus a can be equal to plus or minus 2. Now, the reason that I have to add a plus or minus symbol is because there are two numbers that I can get when I square a that give me positive 4. The values that I can square to get positive 4 are either positive 2 or negative 2. Now, there's been some confusion over, let's say, what is the square root of 4? Some people say that what this surd symbol actually means is that what number, when I square, what number squared gives me 4. And that's actually not the definition of what this surd symbol means. This surd symbol means what positive number squared gives me 4. If I wanted to make a distinction here, if I write negative root 4, this means what number squared, what negative number squared gives me 4. So root of 4 is always going to be 2, and negative root 4 is minus 2. So that's why we need to include the plus or minus symbol when we're solving this equation. That's really important. Lastly, we've got determine f of 2k, and here we're just going to sub in 2k into our function. So f of 2k is equal to 2 times 2k squared plus 5. Now, we're not going to get a number here, we're actually just going to get an expression in terms of k. So let's go ahead, when we square 2k, we get 2 times 4k squared plus 5. 2 times 4 is 8, so we get 8k squared plus 5. Now, if you were comfortable jumping from and skipping this intermediate step, it would be okay to go from this step to this step if you're comfortable with doing this simplification in your head. So f of 2k is 8k squared plus 5. That concludes this video, and we'll see you in the next lesson.